Hi, pre-calculus honors. So this is 8.1, day 2, still on parabolas. And notice we have 3 objectives for today. Be able to write an equation of a parabola. Now, I'm going to give you 2 pieces of information, either the vertex and the focus, or the focus and the directrix, etc. And that will be enough information to write an equation of a parabola. Or I would please be able to write an equation of a parabola given the vertex and an arbitrary point on the parabola. Also be able to complete this square. So we're going to start with problem number 1. And I like to start with orientation so that I can get the general equation. So notice that for this particular parabola, I didn't ask you to sketch a graph, but I think it'll help if you have a visual. So we have 2, -1. That's the vertex, and the focus is at -1, -1. So here's my focus, here's my vertex. So we know that the parabola must open to the left. We actually know a lot because between the vertex and the focus, that is the P. So we know that the P is 3, and it's negative because, again, it's going to open to the left. So I can go up 6, 1, 2, 3, there we go, and down 6, 1, 2, 3, 1, 2, because the focal width is 4P. So I've got a beautiful parabola there. So again, the parabola, it's like the parabola almost hugs the focus, right? Oh, that's a terrible picture, but you know what I mean. So we've got a beautiful parabola here. You could put in the directrix if you want, but they didn't ask us for that. They want an equation. So since it's opening to the left, we know that the general equation has the y squared. We know the vertex. We can slide that in there for h and k. And we also know the p is -3, so that we know -12. So there we go. We've got a great equation. Let's go ahead and try number 2. So this time, you're given the focus and the directrix. 1, 2, 3, 4. Okay, so there you go. So we know that the vertex is halfway between, because every point on the parabola is equidistant from the point, from the focus and the directrix. So this must be the vertex. And so the P is 1, and it's going to open down. So the P is -1. So since it opens downward, we know the general equation. If we wanted to, we could get a pretty beautiful graph, because you could go right 2 from the focus for the focal width and left 2, since the P is 1. Or I should say -1. So now we can write x plus 3, because we know that the vertex is at -3, +3. And then the 4p must be -4, since the p is -1. Okay, so next we're going to complete the square. Now when you look at this particular problem, we see that our parabola, right, our equation is, the equation is quadratic in the variable y. So since that is, the y is squared, we're going to complete the square with respect to y. So I'm going to have you pause the video for a second and try and think about what your goal is. What would this look like at the very end? All right, so again, since the y is squared, the equation is quadratic in the variable y, we're going to complete the square with respect to y. Here's our standard form. So let's go ahead and get started. So let's go ahead and isolate the y terms. Okay, so next you want to actually complete the square. So when you complete the square, you're going to take that, I guess we call it the middle term, 4y, we're going to divide it by 2 and square it, which is 4. So that is the number that makes the expression on the left side of the equation a trinomial square. Now be careful, because you have to keep your equation balanced. So if you add 4 to the left side of the equation, you have to balance and add 4 to the right side of the equation. So your next step is going to be to factor. So now we have our equation in standard form. Okay, so our last example, we have a parabola that opens upward with a vertex and an arbitrary point. So there's nothing special about 3, 5 other than it is a solution to the equation. So we are going to start with our general equation. It opens upward. So again, we're thinking about our orientation to get the general equation. Next, we do know the vertex, so we could substitute the vertex in for h and k. Or I should say the ordered pair, right? So now we really have to find p. So what you could do is use the arbitrary point for x and y. So temporarily we're going to put 3, 5 in for x and y. And you can solve this. You end up with p is 2. So now we have the equation because you can substitute 2 in for p. I'm sorry, you can substitute 8 in for 4p. And we are done. Nice job, everybody.